Water filtration systems are designed to deliver clean, safe water at a consistent rate. But when flow begins to slow, it can disrupt operations, reduce water quality, and lead to downtime or maintenance. While many assume the filter itself is to blame, the reality is that decreased flow rate often stems from internal and external factors. A reduced flow rate in water filtration systems can be frustrating and disruptive, especially when water quality and system performance begins to suffer. While filters often get blamed, the true causes are usually more complex and involve multiple system components and environmental factors. Sediment buildup is one of the most common culprits. Over time, particles like sand, silt, and organic debris accumulate on the filter, restricting water passage and reducing flow. This is especially problematic in systems using cartridge filters, which tend to clog faster, are less durable under high sediment loads, and tend to produce a lot of waste. Improper installation, aging components, and using incompatible replacement cartridges can also lead to unexpected flow restrictions. That's where filter elements like woven wire mesh offer a more efficient alternative. Woven wire mesh filters provide high corrosion resistance even in harsh environments like saltwater applications when using Avista grade materials. Their superior stability, cleanability, and robustness allow for consistent performance with minimal maintenance or downtime, even at similar filtration fineness levels greater than 5 microns compared to the traditional filters such as cartridges. A reduced flow rate in a water filtration system may seem like a minor inconvenience, but it can lead to serious consequences if left unaddressed. Beyond slow water delivery, low flow can compromise filtration performance, damage equipment, and even pose health risks. One of the most concerning risks is reduced filtration efficiency. When water moves too slow through the system, it may not interact with the filter as intended. This can result in incomplete contaminant removal and allow impurities to pass through. Biofouling or bacterial growth is another major concern. Stagnant or low flow conditions create an ideal environment for microorganisms to thrive. Over time, these bacteria form biofilms, which are sticky colonies that adhere to surfaces that clog filter pathways. Biofilms are notoriously difficult to remove and can lead to persistent contamination and system shutdowns. Fortunately, biofouling can often be mitigated through the use of specialized coatings applied to wire mesh filter elements. These coatings are designed to resist microbial adhesion and growth, helping to maintain cleaner surfaces and more consistent flow in the biologically active environments. Mechanical strain is also a risk. As flow decreases, pressure imbalances can occur, leading to equipment damage, leaks, and premature wear on pumps and valves. Mineral deposits and scaling may form more easily under the low flow conditions, further restricting water movement and increasing energy consumption. And finally, water waste becomes a hidden cost. Systems operating more inefficiently may require more frequent flushing, cleaning, or replacement of components. In severe cases, untreated water may be discarded entirely, increasing operational costs and environmental impact. So when flow rate drops in a water filtration system, restoring performance requires more than just replacing the filter. A strategic approach that addresses both immediate blockages and long-term system health is essential to maintaining consistent water quality and operational efficiency. One of the most effective solutions is backwashing, a process that reverses water flow through the filter to dislodge and remove trapped particles. This not only cleans sediment buildup, but also rejuvenates the filter, extending its lifespan. For systems using woven wire mesh, backwashing is especially effective due to the mesh's structural stability and resistance to deformation under pressure. For systems dealing with poor source water quality, implementing pre-treatment solutions like drum or belt filters can reduce the contaminant load before it reaches the primary filter. And for long-term reliability, automatic self-cleaning filters offer a hand-free solution that maintains consistent flow and minimizes downtime. These systems utilize timed or pressure-triggered cleaning cycles to purge debris without interrupting operations, even in demanding environments such as mining, irrigation, or seawater applications. And to further enhance performance, high-efficiency multi-layer filter elements and center-bonded Porostar screens can be integrated to ensure consistent particle retention and durability under harsh conditions. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.